very feeble.
One second. Can you hear me now?
Yeah.
Yes, Manoj.
Okay. Yeah, we can start, right? Has anyone gone through that question paper? I will otherwise share the screen then.
I have the question paper.
Okay, fine.
So yeah, we can start. So we want to go only through the CNN concept, right, Manoj?
CNN, yeah, there's so many questions from CNN. So if we can finish the CNN part, no, then we'll be good to go, I think.
Okay.
Then next time we
Yes.
can take up the other ones, right? What do you think?
Yeah, I think that would be a better idea. That way we'll at least do one section at a time and finish it off.
Yeah, right. Ravi, should I share this screen for the question?
No, sorry, I was sharing and then it went offline. I'll
Okay.
try sharing
Yeah.
again. Okay, let me know if you can see my screen.
Yeah, I can see.
Okay. Okay. So first question: the data for neural network is as follows below. What they're given is the inputs are 30-dimensional data, right? That contains numerical categorical values. Of this 30 dimension, 7 are features like integers, 5 features are like binary discrete data, 6 features are discrete data with 3 or 4 distinct values, and rest of the features contains real data. So we have data with 30 dimensionals, 30D. Okay. Now what they're asking is the neural network has to discriminate between two classes which are mutually exclusive. Okay, so it will basically like identify whether it's a cat or dog. There are 1 million data points for the neural network training and testing. Okay, so what they're asking, design a multi-layer perceptron MLP for the above data with restriction that number of parameters should be between 3000 and 5000. So here number of parameters is like I think the neural network what will be designing and the number of weights that has to be there, which connects input to hidden, hidden to other hidden, hidden to output. Those weights should be somewhere between 3000 to 5000 number of weights, right? You can assume all relevant information and these assumptions should be clearly written. Show that your neural network that you have designed does consider the restriction mentioned above. And write a relevant Python code using TensorFlow Keras library to design and train the neural network. Marks wise, you're saying input layer, hidden layer, output layer. If you correctly show, I think there's 1 marks, computation of total parameters 2 marks, and code according to is 2 marks, right? Okay, so basically I was checking if there is some fundamental rule that says, if you have these many dimension data and you're restricted with the number of weights that you can have. Is there a formula to come? So there's no hard and fast formula. You have to hit and try, right? So if you use ChatGPT, also it will give different answer. So and here is different answer. So I didn't find any specific relation to derive to it. So what basically, if you see a solution, what they're saying is,
Ravi, one question. Yeah, is this actually related to
yes,
CNN or is a general MLP question?
it's more like a general MLP question. But
Okay.
coding wise, if you see, it is coding is more like a CNN based, right? It's not a normal neural network coding.
Coding,
It's normal only, not
it's a
yeah,
normal, right?
general.
MLP, yeah.
Yeah, it's normal. Yeah,
No
thought they
problem.
asked me.
Anyway, I think this is the
Yeah,
same thing what we studied in the midterm, right?
makes sense. Yeah,
Okay,
correct.
yeah, we
So
can
what
go through
we're
it.
saying is for input layer we have 30 input nodes. So
Can
since
we
we have
increase
30
it?
dimensions,
Sorry, can we increase the font a bit size? Little bit more.
Is it okay now?
Little bit more.
Now?
Now it's good. Yeah. Now it's too much. Maybe.
Yeah. Okay, I will just reduce a little bit.
I think 150 will be good.
150 should be good.
Yeah.
Right. Yeah. Now it's good.
Yeah. So first thing what you do is that since there are 30 input nodes, because you have 30-dimensional data, so what they're doing is they will take around 100 hidden layers. Okay. So you can imagine there are 30 input nodes and there are 100 hidden layers, 100 nodes in the hidden layer, right? Now, if you see, and if you assume that you have fully connected neural network, then you can see each of the input will connect to each of the hidden nodes. So you have 30. So have close to 3,100 parameters, which is between your input node and your hidden layer. Considering here only one hidden layer. So next is output. So 100 hidden nodes and a bias will connect to the output layer. So that again becomes 100 plus 1 into, since output is only one, you get 101 parameters. If you see total number of parameters, considering the weights between input and hidden output, you sum it up, it becomes 3201, which is well between our question given at 3,000 and 5,000, right? So second part they are saying computation of total parameters. I think the same thing we have to talk about here also. Nothing different, right? So the number of parameters in MLP is calculated as a product of number of nodes into adjacent layer plus the number of bias terms. In our design, we have, as you have seen, 30 plus 1 into 100. This is for input, and input to hidden, and this is 100 plus 1 into 1. This is for the hidden to output, and this value is 3201.
Ravi, sorry, this one we are assuming 100 nodes, right? So that
100 hidden nodes, yeah.
Yeah, first layer, input layer will be 100. So 100 into 30 is 3000. So in that way,
No,
we are
input
right?
layer 100 is hidden layer.
100 is hidden layer, first hidden layer, right?
Yeah. Yeah.
So,
Yeah.
So 30 inputs, 30 into 100 will be 3000, and then we have 100 again as the parameters. I mean the bias. So 3100 should be there. No, why is the one extra coming up?
It is bias that we are adding. Okay, so that's a bias from the ID.
Manoj.
Yeah.
See, you could either do it as 300 30 into 100 plus 100 or 30 plus 1 into 100. It's both the same, right? So by the number of inputs into the number of hidden layer nodes plus 100, which will be the bias. So instead of that, what they have done is 30 plus 1 into 100. Both will come to the same. You remember the calculation, right?
What I understand is 100 bias will be there. So then 30 into 100 is the other weight. So that is 3000 plus 100. Yeah, so it should be 3100. But they have mentioned 3101.
No. 3000. Did they mention 3101? No, 31. 3100 only. 3100 only, Manoj.
Sure, let me check.
Yeah,
that way.
It's 30 plus 1 into 100 also is 3100.
No, they
or
mentioned
30.
3101. Yeah, in the answer they have. That's the question actually. Why I got confused with
that. No, this one is wrong. This one is wrong. This should be 3201 here. What you see, Manoj, for reference.
That is 3201.
That is wrong. Yeah.
Why is the 3201 actually? It should be 3100,
yeah,
right?
Yeah, I'll explain. So if you see this diagram, right? So there's one bias term. Consider this a bias term, only one, and there are 30 input nodes, right? Now all of this will connect to 100 hidden layer and there's also one bias term here, right? So
this,
each of this
sorry to interrupt. So this 30 is taken as an input or input layer. This one
input. So I'll mention
Input.
here. So it's a
input, no. So
input.
the each one will not have separate bias. No, 30 bias is there. 30
No,
into.
no. There are
No,
30
no, no.
inputs. Bias is only one. If you see here,
Mhm.
I'll color the bias. So this is only bias term. Okay, red one. This here. This is bias term. The rest all are other nodes. Okay. So if you see 30, this node will connect to each of the 100 ones, right? This you are clear with this, right? So
Yeah,
you'll get 30.
that's clear. So 30 into 100 is the number of parameters that coming up, and then we have the 100 weights. But why the 30 weights is coming
Again,
in? Yeah.
yeah, I'm coming back. So this again, this here, this bias term will connect to all the sorry, all the hidden layers, right? This
Mhm.
bias term
That will
also.
be 100
So you
only,
get
right? Yeah.
plus, yeah, plus 100, right?
Yeah, yeah. This is the
So
formula
what
I
is
know
this?
about it. Yeah,
Yeah, so this becomes 3100, right?
yeah,
This you're clear, right?
yeah.
Okay. Now come to this node. This is your output node, right?
Mm-hmm.
Here also all nodes will connect to the output term,
Okay.
right?
Mm-hmm.
And even
So,
bias will connect to here.
Yeah.
So here you will get how much? 101,
Mm.
right?
Yeah.
So if you add this one, 101, you get 3201, right?
Mm.
This is what is described here,
But they have
right?
mentioned 3100.
No, this is wrong. Manoj. Don't see this. Just
don't
go
look
by
at
this.
question B. Look at
Yeah, yeah.
A.
This
Look
is
at
wrong.
in total we have this one. Okay.
Yeah, this is wrong. Okay, if you see, they have written correctly here, but RHS part is wrong. Okay,
Mm. Yeah, then it's okay.
okay.
And Manoj,
Now
you understood why the output is 1 also you understood, no?
Output is one. I didn't check it. Why was the output only one? Is it?
Because
Yeah.
you have to represent two classes. So for two
Only two
classes,
classes. Yeah.
it's binary,
If
right?
it is
So
only two classes, then only one node
one
is
node is
enough.
required.
Yeah.
yeah, yeah,
Okay.
I think this is a Python code, pretty simple. So the defining model and then adding a dense layer, 100 hidden layers and input dimension 30, activation and ReLU. Then they're adding one dense layer. This is your output activations for sigmoid, right? For output they're using sigmoid, and because it's a kind of binary classification problem. Then they are compiling standard code, nothing's different. Loss function, they are using categorical cross entropy, optimizer Adam, and metrics they're using is accuracy. They are giving model.fit, epoch 10, batch size 32. These numbers we can give as per our understanding. This is not hard and fast. Um, and then evaluate, they are evaluating against this, right? X test and Y test and printing test result.
So this approach 10 is how we are assuming that 10 any and batch size 32. We have any thumb rule for this?
This is these are called hyperparameter, Manoj.
Yeah.
You don't have thumb. There are various ways of training it. There's one way is like, you can consider, you can create a grid of hyperparameters where you can say, okay, try from epoch 10 to 20 and batch size 30 to 50. So you'll try all the combination and it will give you which epoch and which batch size has a best result. But there's no thumb rule. That's why they're called hyperparameters. You have to try different values and find the optimal ones. So you can give your own number also. You can give 20, batch size 50. That's fine. There's no thumb rule for this.
So for exam purpose, just put it be epoch 10 and batch size 32. That's it. Don't go
Yes.
for anything further to that.
Yeah. Okay. So this was question 1. Hope this is clear. We can go to second question, right?
Yeah.
Second, yes. Second is actually CNN. The first one was MLP. Actually.
Yeah. This is actual CNN, right?
Yeah.
So what do you see here? You have an input image, right? You have an input image of 227 by 227 pixel. 3 is your you have it's a color RGB one, so you have 3, and then you are having convolution level 1 with 64 filters, convolution level 2 with 128 filters. Then you are doing pooling. Then again you are doing convolution with 128 filters, and convolution 4 with 256 filters, pooling. Then you are flattening, and it's again flattening, and then final output. Right?
Is it flattening or full connection?
Sorry, full connection. Yeah. Full connection. Yeah, complete connection. Yes, sorry. Full connection, and then output. So this is the structure. Okay, what they're saying, a 3x3 kernel with stride 1 is used in all convolutional layers.
Yes.
They're saying that at all con1, con2, con3, con4, my kernel size or filter size is 3x3. Stride uses 1. Okay. Max pooling with 2x2 kernel and stride 1. For max pooling, I think pooling they are using at 2 places, and strategy they are using is max pooling, and stride length is 1. Okay. The number of filters on neurons is shown in brackets. Okay. So the brackets shows your number of filters or neurons. So here you can see there are 64 filters, 128, and here this is fully connected, so 512 neurons and 128 neurons. Assume valid padding. Now, what they're asking, write a Python code using TensorFlow library, Keras library for implementing the above. So now we have to write a Python code for doing this, right? In different stages. Okay. So yeah, I think these are standard libraries which you have to import: sequential and conventional 2D, max pool in 2D, flatten and dense, because we are doing the convolution also pooling as well as flattening and dense layer also we have, right? So we're defining model sequential, right? This is a pretty standard one, nothing else. Then we are doing model dot add, right? So this is my first step, where if I refer here, coming back here, right? I have an image of size 207 by 3. This I have to take as input. So and my convolution layer is 64, which means that there are 64 filters, and we have to apply filter of 3x3 on this matrix. So we have 227 by 227 into 3, this input image. Here we have to apply 3x3 kernel, and this we apply 64 different filters, right? So you can see here we have called conv2d, where we are giving number of filters, which is 64 as a mentioned question. Then filter size by strides, right? Stride is 1 by 1, right? Activation function is ReLU. We'll be using throughout ReLU in the middle layers. Input shape, which is our input is 227 into 3, right? So this is for the first convolution that we are doing for 64 filters of size 3x3, stride 1. Yeah, so this is clear to everyone.
The model dot add, and then that is one line, right? Model dot add, then in the brackets
Yes.
we are giving convert 2D. That's the same like MLP, and here we are putting the con 2D parameter, right? And
Yeah.
then
Yeah.
we have 64 filters as given in the question, 64 nodes, right? For what?
64 filters.
4 filters.
64 filters.
Which means there will be 64 different types of kernels which will be applied, right?
Yeah.
Oh, really? Huh?
Yeah. So that means it will generate a feature set of 64 features will be generated by that layer.
Yeah. So if you see this diagram now, Manoj, so
Mhm.
consider this is the input image.
Which
Here
which
they
one
are
is which one on the right side or this one? Two.
this
Input is
one.
two.
Here I'm pointing here, no? Uh,
Yeah.
Here I'm whichever
Okay.
say
Okay.
the right side. Yeah. So if you see two is my input, right? This consider this one image, right?
Mm-hmm.
I'm considering one image. Now this image, these number of different um, metrics are formed, right? So these are nothing but your number of filters. So consider these are like 20, right? So 20 filters are applied here to create this 20 uh, values here.
Mm-hmm. So it's
Okay.
20.
Isn't it a hidden layer, Ravi?
Um Hidden layer we cannot say here, right? I mean, it's like a
It's
if
a
you can,
convolution layer.
yeah, it's a conventional. You cannot say exactly because, but in ANN equivalent, it's a kind of, but not exactly, not very theoretical hidden layer. It's a convolution layer, right? So the idea is
So here we have 5 by 5 kernel, right, in this diagram.
3 by 3
here
kernel. Okay,
here
in this
In this
diagram.
one we
here
have
if you see
5 by
input
5.
size is 28 by 28 and one dimension. So it's a grayscale,
Mm-hmm.
So no RGB, 28 by 28.
Mm-hmm.
What they are doing is they are using conventional 5 by 5 kernel. Okay.
Mm-hmm.
So what happened? 5 by 5 kernel and yeah, but they have not told like how many filters they have applied.
N1.
Okay.
N1 channels 24 by 24 into N1. What does that mean actually?
Okay. So N1 channel means I think this will be n number of filters applied is N1, or maybe I can check this blog to understand exactly N1 refers to the number of channels, just to be 100% sure.
Because the number of filters decides the number of features, right? And here it looks
Number
like
of,
there are N1 features.
have they explained it or they just use the image? No, they have not explained it. So what happens, like if you consider an image, right? So each image has certain features, right? For example, cat, right, or dog, or whatever, or face, right? To identify face, there will be one filter which will just identify your edges, right?
Mm.
One filter which might identify just your color. One filter might identify your eyes, nose, beaks, ears. So likewise, for each feature, you apply one filter or kernel, right, of 5 by 5. Just example, 5 by 5 to any size, right? Depends on your requirement. So depends on number of features. This input image will be broken into those many features when the kernel is multiplied with this, right? So here it says N1 channels, which means what I'm understanding is they are breaking into N1 features here. Okay, so
Mm-hmm.
which means that 5 by 5, you can imagine N 5 by 5 kernels being multiplied to this input matrix. And multiplication was not very straightforward, it's different multiplication. Maybe we'll see if time permits. It's not like just multiplied. So to derive the this small matrix, right?
So
So
that yeah, so that
yeah,
24 by 24 that mentioned is after the filter. After the filter, we are
mm,
using 28 by 28 into 24 by 24. But
yeah.
the number
So
of
formula
channels,
is
yeah.
so formula is this is your input. Let's say height. This is your combinational height. You subtract both of them.
Hmm.
So 25 minus 5 is 23
Yeah.
plus 1.
Hmm.
That becomes 24. So that's the formula.
Yeah,
But
yeah.
if you are defining, I think stride, then it changes. So you have to consider that as well. There's a different formula
Okay,
for
so
that.
this N1
Don't
channels, here is a number of maybe parameters that we are trying to get
filters,
it. Yeah,
number of
filters.
filters, yeah, that we have applied.
Okay, in
So
our
if you go
question,
to
how
back to our
much?
question,
Hmm.
64, 64 is number of filters.
So,
So what
so
will happen
can you
as
check
per our,
the? Can you please show the question? Yeah, it's mentioned. No, add the first convolutional layer with 64 foot is already mentioned there. Yeah, I can see that.
yeah,
Ah,
64
convolution
filters, right?
64. Yeah, so we have to Okay, so that is in the code we are giving 64 and 3 by 3 is the kernel. Then strides 1 comma 1. They mentioned stride is equal to 1, right?
Yeah,
We are
stride
equal
is
to 1 comma 1. No?
yeah. So what will happen once we apply this? Let's imagine if you apply this, then what will be the new metric? So we will get 64 features, 64 metrics. So we give this one we'll get 64 metrics, and what will be the new size? So new size will be your
227 minus 3, 224
2 to
plus
7.
1, 225, right?
Yeah. So 2 to 7 minus 3 is 2 to 4 plus 1. Yeah, 2 to 5. Yeah, correct.
Okay.
We have to divide by stride also, but stride is 1, so doesn't matter. So when we subtract this 2 to 7 from 3, we have to divide by stride. So here it is 1, so it doesn't matter. But if it is 2, then it changes. Okay. So this have to remember this minus this, but divided by stride, and then plus 1. So 227 minus 3, 224, divided by 1, it remains 224 plus 1, 225. So now this 225 by 225 into 3, this metric will go to this one, second convolution layer. Now second convolution layer, same thing, only difference is that it has 128 filters, and stride is same, and activation is same, right? You don't have to specify an input shape, because whatever is output from here automatically goes to input here. And then you are defining max pooling. So again, max pooling is full size again 2 by 2. That's all you can mention, and then it's fine. Right. And third convolutional network, again same thing will repeat. 128. This is our filter dimension and corner size, and then stride and activation. Fourth.
Can you just explain this max pooling, if possible, that what is max pooling?
Max pooling.
Yeah.
I think I'll pick one
we
diagram.
are taking the maximum of the values in that matrix or something like that.
Yeah, exactly. So if you see this diagram, what we are doing is we are doing 2 by 2 max pooling. Okay. And let's say my stride is 2. Okay. So what does it mean? So 2 by 2 max pooling means I'll take 2 by 2 metric. Okay. And I'll find max of it. So what is max of it? 20. Right?
Yeah.
So 20 comes here. There will be a case where you can also use mean pooling, or you can use average pooling. So it's same thing, right? Mean means minimum you can take, average means you can take average, so nothing changes. Now stride, if your stride is 1, then what we'll do is we will leave this this first row, first column, and I'll take this one. But usually with max pooling, stride is 2, so we will leave 2 columns and we'll take this one then. Okay.
We will leave
so
the columns, but here
stride means your jump. I think here they have taken 2. Okay.
Here they have
so
if you taken the max, they divided by this whole matrix by 4, and from each one they have taken the max, right?
Well, you don't divide by 4, Manoj. Don't think like that. Just think in terms of stride and size. Maybe this helps you to explain better, right?
Yeah.
If you see here,
I'll put the formula. Check.
Yeah. This is n plus 2p. 2p is a padding, minus f. F is a filter of kernel, divided by s. S is stride length plus 1. Yeah, this is correct. Yeah. Thank you. So coming to max pooling, what happens is here we have filtered 2 by 2, stride 2 by 2. So what it means is simple. First we'll take the 2 by 2 metric here. We'll find the max of it. So max is 9, right? So 9 comes here. Now we have to move. Stride says by how you have to move. So by 2 rows and 2 columns, right? So you come here then, right? You move 2 columns here, and you get this metric. And here you find the maximum, which is 7, right? Then this is complete.
Sorry,
then you move 2 rows below.
how we came to 7? I mean 2, and then we are removing the stride 1 means we will go to 7, but stride 2 means we have to go to 3, right? Or what?
So stride means skipping, Manoj. So if
Yeah,
you
yeah.
see this, you are here, right? You are here. Now you have to move. So from here you will move to here. So your stride length is 1.
Yeah.
When you move from here to here, stride length is 1. But if your stride length is 2, from here you will move to here. You jump 2 boxes. You came here, right? So this one becomes your metrics to look into.
Okay.
Right? Right?
Okay.
If you're going to stride length of 1, then you will look into this part. This part.
Okay.
You got it right, Manoj?
Yeah. So 1 is means
Or-
we will go to 2, and if its stride is 2 means we will go to 7. Yeah.
Yeah. So from here again we'll look max. Max is 7. Now again this says how many columns and how many rows you have to move. So this is done. Here we were skipping column. Now we have to come down. So we have to come down by 2 rows. So we'll skip this row. We'll skip this row. We'll come here. Right?
Yeah.
Now here what is max? Max is 8. 8 comes. Again we'll skip 2 columns. We'll come here. Here max is 6. We'll put 6. So this is how max pooling works. Basically it tries to find out the important features out of your entire pixel or points matrix, right? Important points and to focus on.
Right. Yeah. Okay. Got it.
So yeah, here they're giving pool size of 2 by 2, right? Now they've not mentioned stride length, no?
Stride is 1, okay.
Default is 1.
No,
You don't
for
specify
the problem statement which we are doing, stride is 1. It's given.
Yeah, so here we have not defined anywhere stride, no? So what I'm asking is if you don't define, by default it will take 1, right?
I guess so.
Okay. This was my doubt. Okay, fine. So then we're adding the one more convolutional layer. Again, same, nothing fancy about it. Just add the number of filters, convolution size, stride, activation is always ReLU. Again, adding fourth, and then second max pooling. Again, one more max pooling layer. And then we are flattening everything. So flattening means we are just converting everything into one-dimensional vector. So let's say here we have got something like x by y by z dimensional vector. Everything will flatten into one-dimensional vector, and we have x into y into z elements right here in the flattening. So after flattening, always remember, then comes the dense layer, fully connected. So before moving to dense layer, we have to do this mandatory step of flattening the matrix. So basically, if I come back to question, so you can see here they're not talking about flattening, especially over here, but they have said after pooling, you go for FC, that is fully connected. So fully connected means dense. So in between, you have to do the flattening to create a fully connected layer. So maybe yeah, see here. So once they are done with this, all the filtering, max pooling, everything they are done, they are flattening it. So when they are flattening it, you can see there are all single units getting created here, right? So yeah, a simple model.add. Then as per question, we have 2 fully connected after the max pooling. One has 512 nodes, another has 128 nodes. And that's what they have added. Dense layer, fully connected, 512 nodes, dense layer, 122, 128, fully connected. And then your last layer is output layer with 10 nodes. Output, since it is 10 nodes, so it's not a binary classification. We will use softmax. Otherwise, we would have gone for sigmoid, right? So yeah, this is your output. Now you will compile, and so again, pretty standard one. For compiling, you're going to use loss function as categorical cross entropy. Optimizer is the atom, and metrics your accuracy, right? So this is your code. This is understood, right?
Yeah, code I think is a standard code we can use, right?
Pretty standard. Yeah, nothing changes. As per question, only we will change the these values. Yeah. Okay. Second question, they are saying compute the number of parameters learned in conv2 layer. So how many numbers of parameter are there in contour layer? When we say parameters, it means what? It means number of weights, right? How many number of weights are there in contour? So we need to understand from input how many are going to conv1, what is size, and then from conv1 to conv2, right? You have to understand this entire network to answer this. Right. So input images, this one, 227 and we are doing conv1. So okay, I think we have to write somewhere. Maybe I'll just check the answer also.
So how is the
Understanding is
parameters to compute the number of parameters? How do we compute the number of parameters?
Number of parameters will be depending on your
Input channel, then kernel width, kernel height, then number of output channels.
Total numbers.
So,
I think this is different formula.
yeah, maybe.
This is a different formula.
But then, what about the in between those things? Some
Yes, sir.
there were some other stages, no, in between.
So I think for this one, no,
CNN
conv
not
2.
having those or what?
No, it's
For
only
conv
asking of conv 2.
right? Yeah. So you imagine you have put this image to conv1, image of 227 by 227 by 3, right? What you'll get is 225 by 225 by 3 metrics, and there will 64 metrics like this, right here, each for each feature, and then this will connect to conv2. This will go to again conv2, where you will have I think this to calculate, right, 100. Yeah.
Can we calculate that?
So here, yeah, I think we'll have to there's a question also like this. We'll have to do some calculation for this one to understand it. And please help me, guys, because I was not very sure about this.
Actually, for the contour parameter calculation, right, we don't need to take the input size. It's mainly the kernel size and channels, number of channels.
Yeah.
No. We need to
Input has to be taken, no? Yeah.
No. Input need not be taken.
It's not required. Yeah. So, but just for understanding. So, for example, we have taken input size and conv1. So when we come to conv1, we will get 64
features.
Features, right?
Yeah. So input you have taken as 27, 3. Okay. From that, actually, you are only finally getting 64 features, which becomes your input to the next layer. So the conv1 output is 64. From there to conv2, the input is now 64, not the original input, right? So the number of features which are extracted by conv1 is the input for conv2.
So it will be 64 into 128 plus 128, right? And then we have pool 1 in the output. So how to do that? Maybe 3 by 3 or something.
No. So the output is 128, which is okay. So like the MLP calculation, right? So that 120 output will come. The number of nodes in the output. Okay. Kernel size is actually the filter size. Kernel size of 3 by 3 is given. So the formula is given over there. I don't know much. Yesterday also when she was revising, she was going through it. So by heart this. So the formula is number of inputs into kernel width into kernel height into number of output plus number of output. That's the formula. Now identifying what has to be put in this formula is what is required.
Yeah, but here
I think the answer is 3. Answer is 3 into 3 into 1.
No, pool is the next layer, Manoj. After conv2, pool is the next layer. So the question B is number of parameters for the conv2 layer. Not the pool. Pool is another layer, right?
Yeah, but we have to take that one also, no? Because in the output of the convert 2, we have to give to that pool. I'm not sure.
No,
I'm
no,
just
no.
guessing it out here.
Output of the con2 has to be given to the pool. But at the moment, you are only asked to calculate the number of parameters of the con2, not of the pool.
Yeah, so basically,
So
I think
that
whatever is
output
from
of
con1 to
128 is already taken care of.
yeah.
Okay.
So,
yeah. So, Ravi, can you explain?
just,
Yeah.
yeah, I'm just trying to decipher this formula, how they're doing it.
Actually, number of parameters, it depends, is actually the total number of weights and bias. Okay, and you see there are 64 channels, right? If you're talking about 64 channels, for 64 channels you have 3x3 filters.
Correct.
Okay.
Yes.
And 64 multiplied by 3 multiplied by 3 plus for each channel there will be one bias. So 64 bias. Okay.
Yeah.
Something like that actually.
Yeah, yeah. I think this is this is pretty simple. I think we unnecessarily got complicated. This is simple neural network concept only, if I'm not wrong. Whereas let's say just think that you have 64 features, or you can think like, I mean, it's not right to say, but if you try to imagine that there's 64 hidden layer, one, and there's another hidden layer with 128 nodes, right? And we have to connect all of them. But since we have kernel width of 3x3, we're multiplying it like this. And then we have biases, right? So since we have number of output channels is 128, so we'll have 128, one bias will connect to 128 output channels. This is how they're calculating. If my understanding is right, 64.
Can you write it? Can you write it?
Yes, Ravi, that is right.
Is this formula same as whatever Mohammed put it in the chat? Is it for same purpose?
No. What Mohammed put in the chat is the number of identifying the number of what will be the final number of what do you say?
The size. It is actually for the size actually.
Yeah, and that's the size of the output.
Yeah. So now what I would say, guys, just forget CNN. Okay. Think that this is your 64 nodes and this is 128 nodes. There's one bias also, right? So how many weights would be there? How many parameters would be there? Think about it, right? 64 and 128, right here, and we have one bias. So 64 will connect to so one will connect to all 128. So it will 64 into 128, right? And then you have one bias which will connect to all 128. So it will be plus 128. Correct?
Yeah.
That makes sense.
Yeah.
If I put in terms of number to visualize, so it will be 64, which is my first layer, right? And then it will connect to 128 nodes, right? It becomes 128. And then you have one bias, so you will add 128 more, right? So bias will connect to all the 128 nodes, right? But this is in case of normal ANN, right? Or the normal neural network. This is CNN. So we are achieving this via kernel, which is of size 3x3, correct? So we just add this one.
But Ravi, this 3x3 is not in between. If you see the block diagram, they have mentioned this 3x3 is coming after the 128.
3x3.
Oh, Manoj, 3x3 is the filter.
Yeah. So this
3x3 is the kernel.
Yeah. So what will happen, Manoj? Think that this is
block diagram they mentioned. I think it's coming after this one, no?
3x3 is the kernel, which will be see in a CNN. What happened? What's a CNN? A CNN is you have an input. On top of that input, they will apply a kernel and get an output. That is what is one convolution layer.
Praveena, I got it. Yeah, they mentioned a kernel with 3x3 with stride is used in all the convolution layers. Okay.
Yes.
And the pool is only something different. Okay. So
yes.
Okay, I got messed up with kernel and pool. So kernel we are applying in between convolution 1 and convolution 2, right? So we have to
so kernel you have to apply here on this one.
Not in between. Convolution is basically some input multiplied with kernel is what is a convolution.
Yeah.
Okay, so some input multiplied by kernel is one convolution.
Yeah, exactly.
So this
So if you
kernel parameters we are also learning, right? That's why they are saying parameters, right?
Yeah.
Correct. Kernel parameters also we are learning. Yes.
Okay. So it will
Manoj,
be like 64.
here.
Yeah.
Yeah, here when they say max pooling, right? For max pooling, there will be no parameters.
Oh, okay. That's the standard. Okay.
Yeah, that's the standard. If they ask parameters on pool 1, the answer would be no parameters.
Yeah, because we
Zero.
are taking only the maximum among the metrics. Okay. Yeah. Right. That's
Yes.
right. But for in this one we are for 64 into 3 by 3 into 128, then whole plus 128. That will be the output.
Exactly.
Okay,
Exactly.
got it. Yeah. Thank you.
Yeah.
Somebody has to explain C to me. I don't know where that 53 and all that is coming from.
53. Yeah, let's try to see. So this is clear, right? B is clear. Then we move to C.
Yeah, B is okay. Let's go to C now.
B is clear.
Compute the output size after pool 2. Okay. So after pool 2 means after this. Oh my God! After pool 2.
After convolution 4 is the pool 2. So
right.
what happens in pool 2 is what I don't understand.
We have to follow the sequence. I think we can't straight away jump to pool 2. We have to derive the in between layer also, if my understanding is right.
This is convolution, so there is a standard. The 256 is the standard output from convolution.
Output
4,
of the convolution. 256 is the output of the convolution.
No, don't go at 256. This is the number of filters, right? The size is not the thing we're talking about here. I think what they're asking is size, right?
Okay, correct.
Right. Don't go at that. So if you
then we need to start with 227.
Exactly, that's what I'm saying. Compute the output size. They're saying output size after pool 2, right?
Into 3. Now the size after convolution 1 by applying a 3 by 3 filter will be 224.
I think recursively we have to use formula. So we started with here, right? 227, 227 by 3, right? Here we are using 3 by 3 convolutional. So if you see 227 minus 3 plus 1, because stride length is 1, so I'm not dividing by stride. No padding. So this becomes 225. So here we will have 225 by 225 into 3, right? This is what we'll get. 225 into 225 by 64, right? This is what we will get here. Then here again we will get. So we have 225 now. Again from 225 we are applying convolution. So again we'll subtract 3, add 1, we get 223, right? On 223 again we are using pooling. Pooling stride is 1 only, right? Max pooling with stride length 1, right? So this becomes 223 minus 2 plus 1. So this becomes 222, right? Just 1 is reduced.
This pooling means we are dividing by 2, right? Or what?
Same thing you have to use. No different. Same what you are using convolution. Same formula we use for pooling as well. So pooling will become 223 is there.
For example, if there is a 2 plus 2 4 and then 16, then it becomes output becomes 4. No, it becomes root, right? What you mentioned, no? Earlier you show something, no? There were 16.
No, that was because. See, Manoj, there the stride, it was 2, right? Here the stride is 1.
1.
Okay.
Yeah.
Okay.
But the formula for calculation, use same formula, Manoj. Don't use different. You stick to same formula for calculating even in the pooling output of pooling, right?
Ravi, can you repeat the formula once? Like
formula is in chat.
Input?
Formula is in chat. Somebody has given here. Yeah.
So n is number of input.
N is your input dimension. It could be height or width, anything. Yeah. Okay. Yeah. And then
What is
padding? P is for padding.
Okay. If there is no padding, then we can do you have to consider 2?
0. Make it 0.
0. Okay.
Padding nothing is 0, right? Then F is your filter, right? Filter or kernel, whatever you say. filter or kernel, it can say either way. S is your stride, right? So since I don't have padding, I'm just doing n minus f, and my stride is 1, so I'm just doing n minus f or kernel plus 1, right? It's simply I'm using n minus f plus 1 because my padding is 0, my stride is 1, right? So coming back to here, we were till pool 1. We found the pool 1 output will be 222. So it like 222 by 222 metric, right? Now again, I'm applying a convolutional layer here. So again, it will be 222. What is convolution size? 3 by 3. So we'll subtract 3, which is my f or k, whatever you call it, and we'll add 1, right? So this becomes 200, correct? Okay, then this is done. Now 4. Again, 4 means we will add. We'll subtract 2. I'm just skipping this step just to avoid typing. So it become 200. Sorry, not 200. 100. Right? 198. Right? 198. This is subtracting 2 because we are adding 1 also. Right? Then comes pooling 2. So once we apply pooling 2, then we in pooling we were just adding minus, removing minus 2, adding 1. So
sorry, Ravi. The previous step, 222 minus 3 plus 1, right? It's going to be 2018. 218.
Yeah.
How come 200?
Sorry. Yeah, you're right. Thank you.
Okay.
I misread that. I don't have the bigger erasers. So it is 200.
220.
18, right? 218.
220.
Sorry, 220. Yeah.
218, 217.
220, right? Yeah.
Yeah, 220. Then after that 218 and then 217.
218. Again,
and 217.
217, yeah. So this is what we should have after pooling 2, right?
Yeah, that much I did, but still it doesn't come to 53, right? The answer is given as 53.
Yeah.
Yeah, I think it is wrong. They have assumed like it's a stride of 2 for max. 2. I guess. Yeah, that's what I also felt that actually. I also when I tried that.
Otherwise, it will not happen because right now you're getting 217. I did a calculation. Only if you divide that by 4, you will get somewhere around 54.
Yeah, in the max pool, if you assume stride equal to 2, then it comes.
Correct. If stride is 2, then in that case, that will be that will divide by half. Plus 1.
Yeah, 110 by 2, right? 110 by 2 plus 112 by 2. I think something like that it came.
Yeah, 111.5.
Okay,
so that can be rounded to 112.
So as per question, our steps are right then, right? When this is 217 is what we should get. So we'll get none, 217, 217, 256, right?
So what instead of 53, what you are getting?
217. 217.
No, you should get 110, right? Because you have to apply max pool on top of what you got.
Yeah. While applying max pool also, after applying max pool, what will your size output?
It will be divided by 2. It will become whatever you got. So
then I think we did it wrong, right? We did one mistake here, right? Because is it divided by 2? Are you sure? I'm not sure max pooling formula. Max formula
is same only. N minus f by 2, right? Yes, n minus f by s plus 1, same one. Instead of kernel, you have to apply the pooling matrix.
Yeah, then how it is divided by 2? How it is divided by 2? It's not divided by 2 then.
Not 2. Yes, not 2. N minus
S
f by
is 1,
s.
No? S is always 1, I think.
S is 1. Okay, then I think there is something wrong.
S is always 1. So
they have assumed 2 is what we are thinking, because if they had assumed 2,
yeah.
If they assume 223 minus 2 by 2 will be 220.
Okay. So if we go as per question, our answer is right then, right? Just confirming.
0.5. 0.5 plus 1, which will be 111 plus 1, 112. So then 112 will become 110. And then 110 will become 108. Then 108 divided by 2 by 2 will be 106. 2.
219 into 256. Correct?
2 equal to 53. Yeah, if you divide by 2, then it will actually come correct.
Yeah, I think because there are 2 pools, right? Pool 1, pool 2. So if you apply the 2 pools with stride equal to 2, then we'll get the answer.
The answer will
But
come
otherwise,
correct.
yeah. Yes.
Pool 1 and pool 2 are like say con 1, con 2, same similar pool 1, pool 2.
But stride is 1 here, right? Not 2.
Yeah, 1.
Then
yeah, that's what. If stride is 1, if we put stride equal to 1, we are not getting that answer 53. So
that is what that is why
something
we are
wrong
saying,
in
actually.
yeah.
Okay. So we clear the process, right? And as per the given question, our process is right, answer also right? Just want to confirm that. Anyways.
Yeah, I think so.
Going to be asked.
Yes.
Yeah, if we have to get 53, we have to go with stride 2.
Okay. So we move on to the next part then. This we did. Identify the activation function that can be used for last layer and optimizer used for the learning parameters. I think this we have seen the code itself, right? So learning parameters all will ReLU, and the last layer will be just binary 10,
last
right?
layer
So it will be
is 10 output, so softmax.
Sorry, softmax. Yeah, softmax. Yeah. Correct. Now, there in this question, compute when the matrix I is convolved with filter F and max pool is applied on the convolved result. Assume stride equal to 1 combination and 2 for question and 2 for pooling. Okay.
For pooling.
So what they're saying, this is our let's say input matrix, and this is our filter, right? You apply filter with stride equal to 1, and once you have applied filter, then you would use max pooling with stride equal to 2. Okay, so yeah, so this is interesting how we have to find it out. So what we do is we put this metric on top of this one, right? So it's 3 by 3, 3 by 3 here, right? So 13, 12, 14, 12, 13, 14, and 12, 14, 13, right? We'll take this section and we'll find out and we'll multiply, right? So diagonal 1. So what you're going to get is 13, 13, 13, 39, right? So we'll get 39 as a first value, right? And then we have stride length of 1. So we'll consider now this 3 and this 3. Correct? Guys, please stop me if I'm doing wrong or if you're not understanding. And we'll multiply this with again the same filter. So here again we get diagonal element 12, 14, 15. So which is 29, then 31, 41. So here we got 39. The next value will get 41. Just cross check the answer. Answer won't be the same because we have to apply pooling as well, right? I don't know if they have written a step or they directly given an answer. Yeah. So after conversion 39, 41. Yeah. So we are right.
32.
Yeah.
Pooling.
Now we'll apply the pooling. So let's say we have followed this step Guys, you clear with this, or you want me to completely follow the steps to show you how it works?
Pooling we have to see, because see, the thing is we are getting a 3x3 matrix after the first after the convolution, right? And
Yeah.
it's a stride 2 pooling. So the stride 2 pooling, the second factor will not come, right? So there should be only two values after the pooling. Is that correct?
Yeah. So what will happen in this case is, let's say we'll take this one 2x2, right? Pooling. So we'll take this 2 rows and 2 column. Okay. So what is max over here? 41.
41.
Correct?
Yes.
The 41 comes in.
Correct.
Stride
41 comes in. Now we take 2 stride, means we leave this column with this lift column. So we get this and something here which is empty, right? So what is max here? 42. You got 42, right? Now we come down.
That empty is you consider that as empty that way.
You have to consider,
stride, Ravi, stride 1 meaning we have to ignore 39 column, and then we have to shift to 41 column, right? So
no, but convolution is stride 2. Convolution is stride 2. That is why I'm asking.
No, convolution was stride 1, na?
Sorry,
stride 1
pooling was stride 2.
Max
pooling is 2. Yeah, we are considering 2 column, right? So that is called 2
stride means you have to skip. How much you have to jump, right? Stride means what?
One column
one
to
stride,
another column.
Yeah.
One line. Yeah, one line of movement from column to
exactly.
Yeah.
And I think this we have seen, right? Stride means how much you jump, right? So here, if you see, if once
the entire matrix will go. Yeah.
Once I've done the calculation here, I'll jump by two columns. I'll jump this column, I'll jump this column, 2 columns, then I'll come here, and then I'll take 2 by 2 here. Once I'm done here, right, I have to jump to next row.
Answer is wrong then. See, when you're doing the max pooling with a stride 2, the first 2 rows are done, right? It's the third row you are in.
Praveena, it's stride 1. So stride 1 is the question.
Pooling, stride, and 2 for pooling.
No, Praveena is right. What she's saying is correct, because if you see here, assume stride equal to 1 for convolution and 2 for pooling.
Okay, actually 1 stride for convolution, 2 strides for pooling.
Correct.
That is why I'm asking.
If you consider 2 stride, what will happen? When we come to row wise, we'll skip first and second row, right? We'll directly take 36 and below something. So 36 should be here. And then here I will take 36, 37, something below. 37 should come here, right?
And from that perspective also, if there is no more, if you cannot apply the filter fully on it, or the max pool, whatever on it fully, I think we should not be using it.
I think
we should start padding in that case.
The answer they have given is for stride 1 of max pool.
Stride 1.
Even a stride 1, it is wrong. Even a stride 1, it is wrong.
Yeah, 32 is wrong.
If you see this one, right? 42 is max here, the last one, right? And here
that is printing mistake probably. That is 42 probably.
It's actually, if you put 42, if you put 42, then it becomes correct for stride 1.
But where they have said stride is 1, they have done calculation for 2, and where they have said stride is 2, they have done calculation for 1.
Yeah, that's right.
Yeah.
But here the filter size is 3x3 matrix, right? So if we make 3x3 on this convolution result, how it is done?
No, why?
Pool filter is 2x2. If you see in the top right, max pooling with 2x2 kernel. So
okay. So we have to take from part A. Okay.
Yeah. Only the kernel is 3x3. So for pooling you have to take the 2x2.
This question can be challenged because they have never mentioned pool size. See where they have mentioned pool size.
The pool size they mentioned at the beginning of the question.
The question.
I think this is independent question. This is not related to the others, right? If my understanding is correct.
Or no, that
could be.
When there is, that is okay, but when it's applied on the convolved result, since the max pool is given already in the question 1, the assumption should be that we consider the same thing. That could be
it also depends on filter numbers also, right? If say 0000, then what happens? 39 and 41 will go away, right? So they have not clearly given the filter numbers.
No. See, max pool is something like you have to take the maximum of the value. Say max pool of 2 by 2 means you just apply that 2 rows and 2 columns take at a time and see which is the maximum value. Take that. That's all. So you don't need a pool matrix there. We just need the pool size.
Okay. Yeah.
But whatever it is, actually, what we have to do is we have to give our presumptions clearly. Otherwise, then even if we have taken some wrong value, also I think they will grade it.
Yeah. Okay. Some marks will get. Yeah.
Assumption. Yeah. What she told clearly is that one, because sometimes we don't know how they what they think and what we interpret, something like that. But if you our interpretation is correct, presuming something, then definitely they have to, I think, evaluate for that.
Yeah. And in case
taken the stride as 1 and pool size as 2 by 2, right? And only the 32 is a wrong one, right?
Yeah, that's right.
42, no?
Yeah.
42, yes, that's correct. Yeah. So instead of 32, it should be 42.
42. And let's say like if we stick with the question like stride 2, then how do we go about it? Like, do we have to add padding to have
no, I think we can still without padding. Padding you have to add means you should explicitly mention, right? It's not mentioned to add padding, so you can't add now. So you have to apply same thing, right? I mean, let's say 2 by 2 means.
If it's a max pool of 2 by 2 without padding, we 42 the third row and third column will go off.
Will go
never be.
Yeah.
Correct. Values will be reduced. Then.
So only 1 cross 1 matrix we will be getting, is it?
If we apply a 2 of 2.
This is correct. No, stride 1 is correct, right? 39, 41, 37, 48. We got 41.
Based on stride 1, it is correct.
Actually, if it is sorry to interrupt. See, if it is stride 2 means we will get only one value, 41. We will not get any other value. Yeah, it's just a one single value. Because see, why I'm saying is even if you apply the formula, right? N minus P by S plus 1, no? So N here is 3 and P is 2. So 3 minus 2 divided by S. S is stride 2. So 1 by 2 plus 1. And we have to take the floor value always. So 1 by 2 floor value will be 0. So 0 plus 1 is 1. So it will be just 41 will be the answer for the given question with 2 for pooling.
They didn't give
is that
padding,
correct?
Right?
I mean,
so padding,
not padding, pooling
will not be there.
No, not padding, pooling I'm saying.
But you told 3 minus 2, right? So
yes,
2P will become 0. Because
no, not 2P, not 2P. See, when you apply max pooling, right? Any pooling, max pooling or average pooling, what you have to do is N minus. Okay, I confused. I said P, no, so don't get confused. I meant this pool size. Okay, so N minus 2 by 2 means it will be 2. So 3 minus 2 divided by 2 plus 1. So 3 minus 2 divided by 2 will be 1 by 2. 1 by 2 you have to take the floor value which is 0. So 0 plus 1 will be 1.
Okay.
I think that makes sense. But I have seen one calculation, where same situation when stride 2 was taken and they had left with only one column. So they have taken this as well. They've not talked about padding, but they said we'll take this as well for calculation. I have seen this. But what you're saying is making more sense because it aligns with the formula, right?
Yeah, exactly. Yeah.
It aligns with the formula. Okay. So much confusion. What
one clarification. See, the max pooling, whatever the output they have kept, there's some mistake it looks because 39, 41, 37, 38, there 41 is correct. And 41, 42, 38, 42, here 42 is okay. 37, 38, 36, 36, so 38 is okay. Fourth one again 32, it should be 42 only. 38, 42, 36, 37.
Yeah, we discussed that. Yes, you're right. It should be 42. Okay, so hope this is clear now after all the confusion. I think it's all misprint or
one thing actually, just can you tell C, just go there, C1, just now, whatever you are doing there only C. None 53, 53, 256, how it has become?
this one is wrong. We discussed this.
What is the answer, correct answer?
As per the question, and going right calculation, it should be none 217 by 217 and 256.
217. What is the calculation behind you have done?
So this is the formula that somebody has pinged in chat. N plus 2p minus f divided by s plus 1. N is your input size, p is your padding size, f is your kernel size or filter size, whatever you call it. F and k you can call both. And s is your stride length. This formula you have to use.
Dubey, you watch this YouTube link I have shared there. You'll get a much clear explanation.
This one.
That's question C, yeah?
Yeah, that's question C. Yes.
Okay.
How to get the most of Grammarly free. It's Kayla on behalf of Grammarly to tell you all of.
Yeah, I don't know if you guys can hear audio or I have to change some audio setting.
No, we can hear the audio.
You can hear actually. You can run. That's okay.
There's option I can change to device audio. Okay. Okay, fine.
Let us look at some example convolutional neural networks and see how we can calculate the total number of weights or parameters in a network. Here's a tiny convolutional neural network, and this accepts a black and white input image. It's black and white grayscale because the number of channels is 1, so this indicates grayscale image. And the image size is 10 by 10. The height and width is 10 by 10. So here's my input. Now this is functional API representation, as you can see. The output of applying a convolution 2D, here I have one convolutional filter, and the filter size is 3 by 3, so this indicates 3 by 3 filter. So I have an input of size 10 by 10, having only one channel as the input, and I'm applying one 3 by 3 filter. So I have a 3 by 3 filter that I'm applying to this input. So obviously, when we have a 10 by 10 input, if I'm 10 by 10 input, if I'm applying a 3 by 3 filter, one filter, the output will be 8 by 8. 8 by 8 by 1 only, because I only have one filter. So the output of this becomes, after this is 8 by 8 by 1. And then we apply sigmoid activation to it. So what comes out is the same thing, 8 by 8 by 1. But now this is converted by sigmoid. And this becomes my input, and my output becomes my output. So if we summarize, if we run model.summary for this model, then we see that our first layer, input layer, is 10 by 10 by 1. It has 0 parameters because we are using input as it is. Our conv2D layer's output is an 8 by 8 by 1 output. And the total number of parameters it has is 10. So how does it have 10 parameters? It has 10 parameters because this is a 3 by 3 filter. So obviously there are 9 values. Plus every filter has a bias associated with it. So 9 filter values plus 1 bias gives us 10 parameters for the filter. And the activation is still produces, maintains the same. It has 0 parameters, so we get total 10 parameters for this convolutional neural network. Let us look at another example. So in this case, we have once again image of size 10 by 10 by 1, only one channel as input. So this is again a grayscale image, 10 by 10 by 1. In the next layer, we have a convolutional layer with 5 filters, each of size 3 by 3. So we have 3 by 3 filter, another 3 by 3, another 3 by 3. We have total 5 3 by 3 filters. filter number 1, 2, 3, 4, and 5. So when we apply these 5 filters into my input feature map, the output I'm going to get is the first one gives me 8 by 8 by 1 input. This is from the first filter. The second filter will give me something similar, but as a different channel. The third filter gives me one more channel. Fourth and fifth give me 2 additional channels. So my output is actually 8 by 8 by 5. I have 5 depth here. So as we can see, the input is 10 by 10 by 1. The next filter, the next layer, we have 5 filters. This gives me an output of 8 by 8 by 5. The total parameters that we have is each filter has 10 parameters associated with it. Since I have 5 filters, it's 5 times 10, 50 parameters. The next is sigmoid layer. So all of these go through sigmoid, but the shape stays the same. In the next layer, I have 2 convolutional filters, each of size 3 by 3. So if I apply 2 convolutional filters, each of size 3 by 3, so I have 3 by 3 filter, once again, 3 by 3 filter. Now this is where things get tricky. So let me focus only on the first filter. So let me erase this and let me focus on the first filter of size 3 by 3. Now, for this filter to convolve through my input volume, which is 8 by 8 by 5, this filter must be of depth 5 too. So this filter should actually become a volume of size 3 by 3 by 5 in order for me to convolve through one piece of this input. So now we have, so when I convolve a 3 by 3 by 5 filter on this 8 by 8 by 5 filter, the output that I'm going to get is 8 minus 2, 6 by 6 by 1 output. And since I have 2 filters like these, the output will be 6 by 6 by 1. So these 2 concat them makes it 6 by 6 by 2. And the total number of parameters is one filter has 3 by 3 by 5. This is 15 times 5 is 45 parameters plus 1 bias. That makes it 46 parameters. And since we have 2 filters, filter 1 and filter 2, this is 46 times 2, gives me 92 total weights parameters. And then we have sigmoid at the end. So this output of size 6 by 6 by 2 gets passed through the sigmoid, and then the output remains at 6 by 6 by 2. Here's another example. So the input here is a 100 by 100 by 3 image. So
I think this is clear, guys, right? I mean, or
yeah, this is clear.
Do you know what's hiding
based
in
on
your
this, when you're calculating number of parameters, right? So we have to take the third dimension also, the depth of the filter also we need to consider.
Depth of filter, yes, of course, yeah. I think this is the right way of doing it because it gives everything, right? I mean, if we get a question and if we do like this for each and every layer, we'll clear concept as well as we know like what's the shape and how many parameters are there, and at the end we can sum everything to get total number of parameters, right?
Yeah, it looks very nice. And yes, if you we can also give the answer in this way. So I think they will not. Yeah, this is a good way of representation.
Veena shared something in the chat, in the WhatsApp chat. It's related to this one, I think.
Okay. Maybe can you forward this this video to in WhatsApp group?
Yeah, I'll forward.
Thank you.
Can you open the Veena's page on the WhatsApp?
Actually, I'm not in my laptop because the audio problem.
Which group it is?
That is text file. Text file. Yeah. Okay. Text file.
This is only for answer A. Only the code.
This is a code.
Nice.
This is a code thing, right?
Yeah, I think we can run it and confirm whether it is correct or not. Our computation, we can recheck it.
So Idris has shared the YouTube in the WhatsApp.
Thank you, Idris. Yeah, thank you, Manas.
Okay, maybe I can try running this and see. Fine.
No, Veena, you are not audible actually. You are in mute now.
Okay. This is what we're getting as output. So yeah, it's coming to 53, see. So we compare with our result, we were having 22, 25 first one, after first conversion, which is fine. Second conversion 223. But when we're using max pooling, it reduced to 111. Is it because we are dividing by 2? What is stride in max pooling?
Yeah,
max pooling 2D pool
size. Size of max pooling and the stride size.
See, what I don't understand is max pooling size.
See, I think in the code they have given 2 as stride. No, that's wrong. In the question they asked to keep was only 1, right?
Yeah. So this max pooling, when you give pool size, what my understanding was 2 by 2 is the pool size. And stride, you have to mention something like this. So how it is taking stride as 2? It should take stride as 1 only, right? Or are we doing some mistake? Because I don't know. Let me just check this max pooling function.
So Veena pinged that input size divided by pool size, something in the chat.
Input size divided by pool size. So that's almost like half, right?
Yeah. But I don't know why.
Okay, stride we have to give separate as the function says. Pool size 2 by 2, stride none, padding valid. Okay, so stride we have to give by default. So if we don't give, then it takes stride as none. So basically it move by 1 by 1. Okay.
Manoj, is it being recorded? This one is recording?
No. Not showing recording.
The formula remains same, which is input shape minus pool size, right? Divided by stride plus 1. I don't see different formula here. Resulting output when using varied padding option has special shape number of rows columns of. Yeah, input shape minus pool size divided by stride plus 1, same formula. I don't see a difference here. Because what I'm not clear is how it got reduced to this, which seems to match the answer, right? From 223, it almost got reduced by half, right? Almost by 2. Again, if you see here, 7, it reduced by half. And it's taking this floor value. So
what is the first parameter? None.
This is for 4 dimensional. Usually, if you see the shape, it is in 4 dimensions. So you don't have 4th dimensions, it's none.
So what is the stride here?
This is what is confusing.
If they say max pooling with the 2 cross 2,
it means stride is 1, right? If I see the Keras definition.
Yeah, and they are telling us the stride is equal to 1.
If pool size is 2 by 2, stride is, you have to especially mention stride. So this is pool size, 2 by 2 is pool size. And if you don't mention stride, then it takes 1. So which means that after taking stride 1, it is reducing by half. But how I'm not clear, or how it reduced by half.
What you mentioned earlier, you showed something. There the stride was 2, then we found that 16 became 4. So similarly, I think when you make it 1, it should become half, right? If you show that
it will go by this formula.
You are able to hear me?
Now it's
Okay.
We could able to hear you. Yeah.
So this program was given in the rubrics itself, and I'm bringing a link. Can you open that?
Yeah, we have opened that program. We have run this also.
Yeah, no,
What
the
you have-
another link is there in the chat window.
Okay, we open that.
Calculation of parameters, convolution and fully convolution.
So here, in case of,
so if you see the max pooling
Oh,
with
that's
stride
the
2,
uni.
right? The formula is, oh, this is uni.
My task. Okay.
yeah,
Yeah, we
in
know.
case
We
of
know.
max,
Yeah, this program, if stride 2 is there, stride, they are specifying it separately in this code, max pooling 2D, size 2, and then stride equals 2.
So when I change the code, what you sent Veena to stride equal to 1, the count is not coming to 50. It is not changing. So I changed only for 1 and I made some changes to the code. Though the code is not running fully, I'll just paste it in the chat. Okay. So for the second pool, I changed the stride.
Okay.
Value actually. So nothing came, right? What happened? Okay, it's all becoming white, I think. Let me change the color before I send it.
You can add that stride equals 1 and 3.
Is this copy not happening?
so what it is saying is, if there is no padding, if you are applying max pooling, then it will be divided by input divided by 2 and height divided by 2. And if you are applying padding, then it's the same formula, input minus kernel plus 2p divided by 2.
Can you share the link, please, where you're seeing that?
No, I'm just did
Manual calculation.
No, not manual calculation. I use GPT. I put CNN input is 223 into 223 into 64. Applying max pooling 2 into 2. What is output? Then it gave 111 64. Then I asked what is the formula. It is giving the regular formula, and for max pooling it is giving the new formula. When I say what is the formula applying max pooling with the padding, then it is giving the regular formula.
Okay, with padding, without padding, then it's
without it is divided by half. With padding, it is remaining the formula remains the same.
Same.
Yes.
Oh, okay. Actually, there was a concept. Yes.
Sorry to interrupt in the middle. Are we dividing the input kernel size and padding? We are summing it up and dividing it by 2, right? Or only we are adding, dividing only for the padding. I need more clarification.
Only. Yeah, please.
I changed this stride for pool, and this is the value which we are getting. With the original code, we can compare, right? So I changed the stride to 1 and 1.
No, I was asking for the original.
When the padding, when the padding is there, what is the formula? When without padding, what is the formula? That's right.
Padding we are not using at all, right?
So there is no padding at all in this case, and even if there's padding, it's just that the original value will increase by whatever is the padding size, right?
2 or whatever it is,
So the original code which Veena sent without the stride had 53. Now when I'm doing with stride equal to 1, it is coming to 106.
Praveena, if you see your code also now, in the pool 1, the size is reducing by half. Have you changed stride to one
only,
there?
Yeah, I changed it only for one of it to see the difference.
Between the last second one. So
Yeah.
pool 2, right? So it remains same, yeah. It didn't change, yeah.
Pool 2, I changed it to stride 2 because I wanted to see the difference. Sorry, pool 1 I kept it default. Pool 2 I changed it to stride equal to 1.
Yeah. So it didn't change, right? Same. Output size 107, engine 106. Okay.
Correct.
So which means that if we are not specifying the pool size, it's by default taking stride equal to 2, right?
Yeah.
That's what is happening.
By default stride. Okay. By default stride is 2, it is taking.
Right. But in the question, it is given as stride is 1.
No, not by default stride is 2. By default, the stride is the size of the filter.
Okay. Stride is the size of the filter, it seems.
Size of filter. No. Stride
then 3, right?
No, 2 by 2, right?
2 by 2.
There's no.
Pool is 2 by 2.
Size of the pool then, not the filter.
Oh, sorry, size of the pool, correct.
Okay.
Yeah.
No, I tried.
We should remember this one. It's very important in confusing. Because size of the pool is the default size of the padding.
Why are you talking about padding?
Sorry, stride. Yeah.
Size of the stride size for pool is the default of the pool size itself.
Right.
By default, pool stride equal to
stride size. Pool size.
Yeah.
I'm sorry.
Yeah, that's correct. Actually, it's a Python default thing. So I think when they gave the solution, they did not think that it would be stride 2. They thought that it would be stride 1, and that's how they gave the solution, I guess.
Right. So can you write the equation there, or can you repeat once again? What is the final conclusion?
I have pinged the chat. If is it correct?
Yeah.
Yeah. Default stride for pool is equal to pool size.
Stride.
Default size of the size stride equal to pool size. Yeah. In Python code, actually, one mentioned that it's only Python code. But whatever, is it the same for the normal formula also? Only for the Python, it will take like that.
See, it's for Python only. See, for normal means they should give the stride, right? Otherwise, we cannot compute.
Yeah, correct. Yeah.
Okay.
I think pool size, dimensional of pool size, right? Not pool size. Meaning 2 cross 2, maybe.
That's the order of the matrix, no? The 2 by 2 means it's 2.
And make it as precise as possible in
Yeah. So it's going to be 2D, like dimension of pool size.
Correct.
Yeah.
Okay. So this is clear then, I think. This stuff is
yeah, but of course we got some research on this. Yeah.
So there is another catch. The max pooling, right? Max pooling will be always even number. There cannot be 3 by 3 or 5 by 5.
And filter will always be odd number.
No, even number.
Yes.
Yeah, filter.
Actually,
always odd number.
Yeah, actually, it was specifically mentioned there. There is a reason for that. Why? Because
so filter is kind of kernel. Okay. So kernel we find something centered around, right? I vaguely remember the logic. So if you have to find something midpoint, then it should be odd number, right? Then you have equal number.
Correct.
Basically like that. You have to find the boundaries.
Yeah.
So think of the screen as black and white. You have to find boundary and differentiate. So something should be at left hand side, something at right hand side. So it's always an odd number, because when you multiply the creator kernel with the matrix, you get a boundary for that feature.
Correct.
So it should be always odd number.
The movement is easier. Actually, we don't leave anything. Everything will be properly taken to computation. I mean, I couldn't able to frame it properly, but I have something in my mind. Yeah, it should be odd. That's it.
Okay, so we move next question then.
Yeah.
Yes. Yeah.
We need to stop before, right? We have
4 o'clock. We have a PGM. We have a PGM at 4 o'clock.
And last class, we don't know what all he'll
Last class, actually, yeah. He will teach the same thing only, Praveena. He will not say what are the important questions. He will focus where. Nothing he will tell. He will just continue the same thing where he stopped yesterday. That's it. Last class.
But good thing is in PGM they are giving mark very liberally.
Really?
Oh no. Who told that?
Zero or full mark.
Yeah. Maybe you got it. You are also in the PGM.
Yeah, in PGM.
Okay, but how many you got? Or 30 out of 30 or what? It seems.
I even though my one answer is wrong.
Yeah, you got full marks, sir.
Not yeah. Because I didn't. I was on a business trip. I did not study, but still I thought, okay, I will at least go.
And how much
do
you
only
got?
2 questions.
Yeah, how many marks you got it finally?
No, 10 marks. I answered 2 questions.
No,
I got 10 marks.
Oh, that's okay, but
even for people who answered all the questions, he gave
all the questions also pill 10 marks. You got. That is also difficult. You don't know that the uniformity and the they have the blanket. Okay. Oh, that's why you're telling like that. Okay.
So next time you guys also write only 2 questions. Okay. So practically is taking
unless your name is Sumil.
Evaluation.
Sumil.
Same marks.
Yeah. There is a it's a max pooling. It's limited.
Here I just in this text file, right, I put all the combination of convolution and max pooling. So if you check there, if you open the text file, then you can see when max pooling without padding, it is divided by 2 or divided by number of size.
No, not like that actually. See, that you have to apply the same formula, no? N minus pool dimension divided by stride plus 1.
No, that is correct. But see here, I don't know whether you can open the text file or.
Where have you sent text file?
No, I pasted in Teams only, Teams chat only. But I think it's still yeah. Can you check now? It is shared. So I tried 3 combination, normal, kernel and max pooling. 2 by 2 and max pooling 4 by 4 and max pooling 2 by 2 with padding 1. For max pooling window size. And if I go for 4 by 4, then it's 223 divided by 4. But the same max pooling 2 by 2, when I go with padding 1, then it is going with the regular formula.
So
Thank you so much.
Is, this one will be 223 minus 2 plus 1 at this layer. Here I'm talking about, right? Oh, sorry.
Yes.
221, right?
So it's all the same input size. I just want to see how it is calculated for each.
max pooling 2 by 2, and what is stride here?
Stride for 0. I mean, stride is 1.
Then it will same formula, no? If you take a stride as 1, it will be 223 minus 2 plus 1. And if you take stride by 2, then it becomes 223 minus 2 divided by 1 divided by 2 plus 1.
No, max pooling, it is directly dividing by pooling.
This formula we have not got anywhere. From where you got this formula, we have not seen anywhere.
Because if the program output is also same, then I think this is the formula.
No, program output is same because that's what we discussed, right? It's because by default stride of pool is equal to pool size. So if my pool size is 2 by 2, then my stride becomes 2. That's
if the the difference comes in odd number, then it will fail. It will be okay for your answer. But if it is even number, right, it will not obey. Say for example, if n is let's say like 8 and pool is 2, right? Then it will be 6. So 6 plus 1, 7 will be the the answer, right? So in your case, how it will give 7?
Second part. So I think we can move on to next question, right?
Yeah.
We are good here. Right?
Next question, I'm not sure what is this. Consider 1 by 3 convolution. Okay. So this convolution of 1 by 3. Okay. Okay, so this is the one, right? Operator O. So 1 row 3 column, -1, 2, -1. This is our convolution. Okay. Output is generated by stacking 2 such operators on a 1-dimensional input data. Okay. So we have 1-dimensional input data. And on that, we will apply this convolution twice. Right. What is the size of equivalent operator O that gives the same output when applied only once to input data? Okay. So what they're asking, what will be the size of operator O, which can be applied only once to input data but gives the same output? What is happening here?
1 plus 3 convolution.
I think here the cross correlation is used.
There will be 2 convolution layer.
Yeah, but first we have to perform the cross correlation. So in order to get that equivalent operator, right? So cross correlation is like write the elements like -1, 2, -1 in the row and as well as in column. Then multiply each and put it as a in a table. Then if you diagonally take the numbers and add up, you will get the cross correlation values.
-1, 2, -1. 1 by 3 convolution. Operator O.
Actually, I'm not in front of the thing to show how it is.
It's a one
let me. I'll just send a picture.
It's a one-dimensional input. So where is the
just
input?
give me a minute.
It's a one-dimensional input, right? So On top of that, you put the convolution. So the first 3 elements and 1/3 convolution. What does consider a 1/3 convolution? What is a 1/3 convolution?
One filter 3 times.
So this matrix size of convolution, right? So we were seeing 2 by 2 or something, right? But this is 1 by 3, which means that
if it says it's a 1D input.
One row, 3 column. Yeah. 1 row, 3 column. This is your convolution matrix. Or filter, you can say. This is our filter.
Oh, yeah.
Filter. I have sent my notebook screenshot.
Twice.
Yeah. So we have to for this kind of question, right? We have to calculate the cross correlation. That means whatever they have given, like output operator, that when they say we need to apply twice, the stacking twice means you need to do a cross correlation of one time cross correlation you need to do. So
what is the one time? Does it mean like you have to multiply it?
Yeah, I'll explain. Can you go to that screenshot? I'll explain how to do that. Yeah. So you write the on the left hand side write the numbers -1, 2, -1. On the top also you write -1,
like this,
2,
right?
-1.
Like this, right?
Yeah. I mean, if you go to the thing, yeah, that's like that. Yeah. I mean, if you go to the screenshot, it will be clear. Yeah, that's one. Yes. So and then you multiply row each number, like -1 into -1, that is 1. -1 into 2 is -2. -1 into -1 again 1.
Okay. Like this, right? So
yeah. I mean, it's very easy to follow in the notebook itself because it's not much.
Cross correlation means what? Cross convolution means this one, just multiplying row with the column, each parameter.
Exactly, multiply row with the column. So then after doing that, right, just you group it diagonally like this, from top to bottom. So that, and then add it in the whatever I have circled, right? You need to add those elements. So 1 -4, 6 -4 and 1. So that will be the answer.
So this grouping based on what you have done, you might have
this is the way cross correlation is calculated. I don't know the exact reason why we are
what
doing.
Is the rule? Actually, some cross correlation because the right side diagonal wise you are taking. If I have taken opposite way diagonal, based on what criteria I am grouping that one? Any rule?
No, it's the way we have to do cross correlation. That's all. I also don't know why it is calculated that way. But this is the way I tried, multiple, websites and found this easy way. Otherwise, they are doing in some complicated way also.
Means we did not bother about the value, whatever is there. Just we will group like this way only. That's all. No?
Yeah. Exactly. You will group like this and add them and put it. That's it.
Suppose 1 -2 -2 means -4.
Yeah, 1 -4. So you see that the group, no? Can you go to that? Yeah. So you can see first one is 1. Second is -2 -2. So that will be -4 if you add it up. Then the third one will be
multiplying. Sorry, adding or multiplying?
Adding.
Adding. Okay. So -4. Okay. Yeah.
And third one, 1 4 1 will be 6.
6 again -4, then 1.
Yes, exactly.
So if I go back to the question, so this is what we get, right? But how we are driving the A part? This was not clear also. B part, okay. What explained makes sense for B part? How are we driving A part?
It's the same question. Same question. See, if you count the number of elements, it's 5, no? That's it. So A and B are related only.
Why so breaking? Didn't get you.
No, it's the same question. If you see the number of elements, it is 5, right? The output.
The number of elements 5. Yeah. So height remains 1 because there's only one row, and that width
Yes.
Now, what
but
is
how
that,
we are grabbing this formula? 2 into 3 minus 1.
Yeah, what is that question one actually? How you are making height of O equal to 1 and width of O is 2 into 3 into minus 1? How? 2 into 3 minus 1, 6 minus 1, 5. What is that actually calculation? Based on how actually height of O equal to 1? Operator.
See, 2 times you are applying, so 2 into 3 minus 1. That's the formula they're given, but if when we calculate itself, we are finding
based on 3, how 3 came? 2 into 3 means 3 how? And minus 1.
3 is 3 operators, no? O1, O2, O3. Minus 1, 2, minus 1.
Okay. 2 times we are doing is 3 operator. Minus 1, why?
That's the formula, I guess.
Okay, it is totally doubt.
This is cross correlation. I think this was there in our PDF, right? Which topic it is covered? Any idea? Correlation and convolution. Yeah, this is the one.
No, but I don't think this question which is asked is anything to do with that cross correlation.
But what exactly that question asking to do, that's also not clear. How to do that?
It's not clear with question.
Yeah, that is not clear. Yeah, anybody can explain that, it will be good.
If anybody understands what exactly it is trying to say.
Do such operators on 1D input data. Okay, so I have okay. This is 1D convolution. That is what we need to check. 1D convolution was the first, I think, is 10th or 11th lecture.
Yeah, but see, because they have not given the original input, right? So it doesn't really matter. So we have to understand that if they they apply it twice, we take the cross correlation. I mean, for exam point of view, I'm saying.
Okay.
For detailed understanding, we may need more. But for exam point of view, we can assume that we need to do the cross correlation and perform this table, so that will be easier. Easily we can find out and answer that.
See, what you said is, I think, and now a little bit, I'm getting some idea. So what is happening basically is, if you see, they're saying apply O twice, right? So which means that they're multiplying O into O, right? So it's a one-dimensional metric. If you multiply, you get the same result as you can do via this Excel sheet, right? Whatever is in cross correlation. So
thing is, if you consider it as a matrix, we cannot multiply because we cannot multiply.
You're right. We cannot.
Non-square matrix with itself, right?
I think it is how they are doing it. They're multiplying it, right? -1 into -1 into.
See, that's what when they say multiply, it's cross correlation only they are doing, and for that only that method whatever we discussed will help. So with that we can
same thing they are doing. So this they're multiplying with first element with every element here, second with every element here, and third element here, and they're getting this metric. This is what you're calling O square, right? Now, what they're saying is the size of equivalent operator O square that will give right, and they're asking what would the size. The size would be same as O, which would be multiplication of these two, right? Which makes sense also. In this case, it is 3 by 3 as per ChatGPT. So what it's saying is 3 by 3 will give the right output, but answer is different. I think right? Answer is what? Answer is saying 1 5. How come 1 5? 5, okay. And if you do cross correlation of this, you get 5 here. If I have to frame answer in frame, but I don't know how this is working. Here, I think height is 1 because we have only one row, so 2 into 1 minus 1 becomes 1 only. But width we have 3 columns, so it's becoming 5. And this is, of course, here some cross correlation is happening, and we're getting this value. But not confident on this question. Okay. What should we do? Should we move next? Because this is so it's clear. Yeah, it says cross correlation sliding dot product over the images. That's how they are taking dot product. So it's not a matrix multiplication, it's a dot product actually. Then after that is nothing.
Any example is given down the way?
No, now they're comparing cross correlation with convolution. So cross correlation is a dot product, right? And convolution is not dot products. They're showing difference of this. So this is your kernel AUV, and this is your kernel AUV, and this is your matrix I plus U, J plus V, and I minus U, J minus V. I'm not sure what is I and J here. Values they're getting is same. Okay, what shall we do? Shall we move next? Because like this one, I think, yeah, we'll have to do the same technique, cross correlation and multiplication, and get to this value. And I think here the formula is 2 is the number of times it's applied, and then this 3 is your width minus 1.
Height of operator means this is one dimensional. That's it.
Yeah. So if you do, if you apply same logic here, 2 into height, which is 1 minus 1. So that becomes 1, right?
2 into 1 minus 1, okay. And width also 2 into length of the operator. So in this case, 3, but okay, yeah, 2 into 3.
Yeah. I think this is what we have to do for this question.
But did you get this formula anywhere, any places?
No.
But you are just trying to map it, that's all.
Yeah.
What about the other question, B and capital B, that different question, that is?
This one, right?
Yeah.
This was different. Consider 3 by 3 operator and 7 by 7 input. 1, 2, 3, 4, 5, 6, 7. Yeah. So I think this is operator, this is input. Point ij corresponds to ith row ranging from 1 to, okay,
from top to bottom.
And jth column ranging from 1 to 2 from left to right. Okay.
Yeah.
What they're saying?
What will be the output size for two dilated convolution with padding 0 and stride 1?
What is two dilated convolution?
See, two dilated means the kernel you should not apply directly. We should leave one row and one column in intermediate, like how they are shown in the second diagram, second table. So say for example, first time when you apply, it will cover 0.5, and then the third row 1, and the fifth row 1, and the third row, yeah.
Third row, second row, right?
Sorry, not third row. Sorry, column. Third column. 0.5. Third column. That is first row, first column. First row, third column. First row, fifth column. 0.5, 1, 1. That will be the first thing. And the second row will become like 0, 0.5, 1. So you should leave one row before that and one column also in between. So like that you have to calculate.
Oh my God. So you're saying alternate, right?
Alternate, yeah, exactly. So one row you should leave and one column. So basically,
and,
like
it says two dilated, and if it says two dilated, then why we are leaving one? I'm just trying to think.
See, when we say two dilated means that is what they mean. So one, if it is just one dilated means it is no dilation. Same, whatever we are doing currently.
Okay.
Yeah.
So same thing we have to do, but only thing is that we have to leave one row and one column.
Correct. One column and one row. Together.
So what you're saying, what output two dilated column with padding 0, stride 1. So if we apply this, so what will happen is -1, 0.5, 0 will be multiplied to this one, -1 will be multiplied to this one, right? And likewise.
Yeah, but they haven't asked that, but yeah, you can calculate. Yeah, that's fine. Yeah.
7 into then again 0 into 0, then 4 into 0.5, then 0 into 1. But see, this is something else they're getting, right?
No, that is 2, 1. So second row, first column. What you have calculated is first row, first column.
Here, which one is first row element, 0.5 or 1?
First row is 0.5, but in the output they are asking, if you see question number B, they're asking value at 2, 1 in the output plane. That means second row, first column they are asking.
No, question A only let us do first. We should understand. First row means 0.5. A only let it be. What will be the output size?
Question A is just they are asking the size. Okay, they are not asking the value. So if you want to calculate the size, means see how many strides we can make with this dilation. We have to see. So if you see that 0.5, 0 and 0, right? The first, the first row, third row, fifth row, that is first dilation. Yeah. Second stride will become second row, fourth row, sixth row.
And
right. Third dilation will become third row, fifth row, seventh row. Same for the column also. So 3, so that we will get 3. 3 by 3 will be the output.
Now, what will be the output size? 7 plus 2 into 0. How it is coming? Can you explain?
7 plus 2 into
Okay, same formula they're using, right? So my size
Padding.
is 7.
Yeah,
okay?
7 plus 2p minus.
Right?
Yeah,
Padding is
right.
0, so 2p minus then kernel is my 3, right? And then again
minus 2 into 1.
Doing.
Yeah.
Minus 2, I think it's because of this one. 2
because
dilated.
of the two dilated convolution. Yes.
Okay. So I think this is the extra term they're adding. Minus 2 into 1. How much dilated we want? And then plus 1.
Yeah, yeah.
7 is the 7 is the total operator order dimension.
Yeah, 7 by 7 input, no? 7 by 7 input. So
Yeah,
the size is 7. Yeah.
Plus 2 into 0, how it is?
This is padding, 2p.
Okay.
Padding. That is 0 only, no? Yeah.
Okay.
So we don't need to include here.
Yeah, minus 3.
Kernel, K.
Kernel, okay. Minus 2 into 1, how it has come? Minus 2 into 1.
This is new thing. This is new thing, I think. Right? I'm not sure. I think
yeah, this minus 2. See, minus 2, the 2 is the 2 dilated and 1 is stride.
Stride used to be divided, no? Used to divide by stride. No? Why it is multiplication?
Yeah, this let me check any formula.
Actually, any general formula
was this taught in class? Was this taught in class?
Yeah, I think.
I don't know. I never attended actually. I just checked only the.
We can start 7 o'clock again, I think. People are moving, I think.
Okay, we'll take a pause here then and we'll resume again in the evening 7 o'clock.
Yeah, that will be good actually. And if anybody can get the general equation for doing this kind of thing, because certain cases we are just assuming, but general calculation, because if they changes little bit, it will be problem for us to solve the problem.
Yeah. This for this we can get the formula. I will get and put it in the WhatsApp group.
Yeah. Maybe we can start 7 o'clock. We can start once again.
Yeah, I'll put it in WhatsApp. Yeah.
Okay. Thank you.
Okay. Thank you all.
Thank you.
Thank you all.
Thank you, Ravi. Thank you,
Thank you.
Manoj.
Bye.
Thank you all. Bye. Thank you.